Okay, so let's talk about inverses, inverse relations and functions. We work mainly with the functions, but inverses, this should be a review from Algebra 2. Okay, so it's something that you have done. We'll do like a little extra piece to it. But so what is the inverse of a relation? Okay, it is a relation that exchanges x and y and is a reflection in the line y equals x. Okay, so it exchanges x and y. Whatever x is becomes y and vice versa. And it's also graphically a reflection in the line y equals x. Okay, so our notation for that, if I want to say I have this relation, the inverse is, looks like it's to the -1 power, but it's not. You don't say r to the -1. It'd be the inverse relation. Okay, so since literally all we are doing is exchanging x and y. If you have a relation just as a set of ordered pairs, it is super easy to figure out. So if this is my relation, then the inverse of that, this ordered pair, which is 0, -7, becomes -7, 0. This one becomes 2, -1. This one becomes -2, -4. And this one becomes 3, 6. Okay, so that's all it means. Literally, they switch places. Okay, so let's talk about functions and what it means to be a one-to-one function. It is a function or a function has a one-to-one relationship It's a one-to-one relationship if the relation and its inverse are functions. And I'll explain what that means. So a function has a one-to-one relationship if the relation and its inverse are functions. So if you start with a function, you take the inverse, you end with a function, that's what's called a one-to-one function. And we can check that algebraically, but we can also check it graphically. So we're going to look at the graphic part of it first with the horizontal line test. So you already know the vertical line test. That's how you know if it's a function or not, right? So if it passes the vertical line test, we know it's a function. So the horizontal line test, let's talk about this. It says, recall, the vertical line test is used to determine whether a relation is a function given a graph. The horizontal line test is used to determine whether the inverse of a relation is a function. So I don't have to actually find the inverse. I can just do the horizontal line test and then see if it would be a function once I got it. So both a relation and its inverse must be a function in order to be a one-to-one function. So let's see what that means here. So if I look at number 1, so it says to determine whether or not they are one-to-one functions. If I look at number 1, is number 1 a function? What do you think? Yes, because it passes the vertical line test, right? So does it pass the horizontal line test? Yeah, it's the same kind of thing. So that means since it passes both of them, the answer is yes, it's a one-to-one function. It's that easy. Is number 2 a function? Does it pass the vertical line test? Yes. Okay. Will it pass the horizontal line test? No. So it's a function, but its inverse won't be a function. So this is a no. It's not a one-to-one function. On number 3, we have 2 asymptotes, one here and one here, okay, that don't have anything to do with the test, but you just need to know you have them there. Is it a function? Yes, it passes the vertical line test. I know this looks like it gets pretty vertical, but it doesn't get exactly vertical, so it's fine. It's totally a function. Does it pass the horizontal line test? Yes, it would pass that as well. So then yes, it's a one-to-one function. So you do 4, 5, and 6, and let's see what you think. So what do you think about number 4? Is it one-to-one? Yes, very good. What about number 5? Is it one-to-one? No, because it passes the vertical line test, right? But then the horizontal line test, that's bad right there, so that's a no. All right, what about number 6? No, because it doesn't even pass the vertical line test, so then it's just a no right there. Okay. We good with that? Any questions? Keep kicking this thing. All right, so let's see what happens algebraically. So our inverse functions. And I gave you the notation for an inverse relation. We really don't talk about those much more than just introducing this. So the inverse of a function, f of x, is written as f inverse of x. Again, it looks like it's to the -1 power. That is not an exponent, okay? F inverse of x, or the inverse of f of x. And not all functions have inverse functions. They have inverses, but they're not necessarily inverse functions. Basically, it's saying every function isn't one-to-one, but we just saw that, so hopefully that makes sense. So here are the steps. We replace f of x with y, so we have x and y. You switch x and y, solve for y. Rewrite as the inverse. So this says to determine if it has an inverse. If yes, find f inverse and state any restrictions on the domain. Okay, so let's talk about domain and range. If x and y switch places, then domain and range also switch places. Does that make sense? Why? Because x is domain and y is range. So for my original function, I want to think about the range of the original function, and that will tell me about the domain of my answer. So if I look at number 7, first of all, I want to think, what does that graph? What's that graph going to look like? It's linear, okay? So I'm going to have a line. Is that line going to be a one-to-one function? Yes, it is, right? There's only one well, there's two that's not vertical and horizontal. Clearly that's not vertical or horizontal, so it's one-to-one. So since it is, then I can move on. If it's not one-to-one, I don't even have to do any work. Then I want to ask myself, if it's it helps me anyway to visualize these things and maybe write them down. It doesn't have to be perfect. I'm not trying to graph exactly, but my line would look something like that, right? Okay, so that's how I know, okay, that's one-to-one. But then my range, is there any restriction on the range here? Or is it all real numbers? It's all real numbers. If there's no restriction on the range of the original one, there won't be any restrictions on the domain of my inverse, okay? So there's no restrictions there. I can just move along and do this. All right, so I'm going to replace f of x with y. So this becomes y. This equals y. Then then x and y change places. So that will give me 4y minus 8 equals x. Then all I need to do is solve for y. What would be the next thing I do? Add 8. Good. So 4y equals x plus 8. And then I'm going to divide by 4, right? So since I know it's a line, I'm not having to graph this right now. But if I did, I would want it to look like what I want. So I'm actually going to divide every single term by 4. So y equals 1/4 x plus 2. And that is the inverse of f of x. Right there like that. Okay. What questions do you have? We good? Easy enough? All right, so let's look at number 8. Number 8 is a cubic. And so if I just did I know what the parent function looks like, but I kind of want to think about what this would actually look like. This would be a vertical compression, and then I would go down one, so it's kind of going to look like that to some extent, right? So remember, I'm thinking about the range of my original one. Is there any restriction on the range, or is it all real numbers? It's all real numbers, so I don't have to worry about the domain and range thing. So this becomes y. Then I'm going to exchange x and y, so I will get 1/2 y cubed minus 1 equals x. My goal is to solve for y without making up math. So I'm going to add 1 to both sides, so I get 1/2 y cubed equals x plus 1. Then what would I do next? I divide by 1/2, which is the same as multiplying by 2. Okay, very good. So I'm going to multiply both sides by 2, so I get y cubed equals 2 times x plus 1. And I'm just going to leave it like that. I need to still trying to get just a plain old y. So how do I undo a cube? Cube root. So I'm going to take the cube root of both sides. So y is equal to the cube root of 2 times x plus 1. And that's all underneath the root, so make sure that it's obvious that that's what's happening. And then that is f inverse of x. What questions do we have? All right, so let's look at number 9. This is a parabola. I would move to the right 4 and up 6, so it's, something kind of like that. Is that a one-to-one function? No, it's not, right? It fails the horizontal line test. So it's not a one-to-one function, so I can just say no. I'll just say not one-to-one. So I can't find the inverse function if there isn't one, right? Can't even do that one. Number 10, we're not doing because we haven't talked about those functions yet, and I don't want to make it any more complicated than it has to be. So let's look at number 11. I've got, this is a square root function, right? So I want to think about kind of what this looks like. I'm going to reflect in which axis? X. So we know that the parent function looks like this, right? But this is on the outside, so we reflect in X. So I'm going to reflect, it's going to reflect down, and then I'm going to move to the left 2 and down 7, right? So it looks something like that. Just kind of ballparking it. Okay. And so is that a one-to-one function? Yes. Are there restrictions on this range? Or, yeah, it is. Okay, so the range of this, remember I'm looking at the range of this one, that will help me with the domain of my answer. So the range, where do I start? What's the smallest y value I could have? Negative infinity, and then I would go to where? -7. Do I include -7? Yes. And do you see how having that little sketch can help you with that? It can help you kind of visualize what's happening. That's the range of my original one. So when I get to the end and I need to talk about the domain of my new function, we'll write that down, okay? So let's look at finding the actual inverse. Make that equal to y. So that'll give me negative square root of y plus 2 minus 7 equals x. All right, so I'm going to add 7 to both sides. I'm going to get negative square root of y plus 2 equals x minus 7. Then I want to get rid of that negative sign, so I'm going to multiply both sides by a -1. So I'll get the square root of y plus 2 equals negative parentheses x minus 7. And I'm just going to leave it like that because we're not going to graph right now, but if we did, then I would want it factored out. I don't want it multiplied in. So now how do I undo a square? How do I undo a square root? I square it. So now I'm going to square both sides. This will give me y plus 2. That's equal to negative, then x minus 7 squared. Then I'm going to subtract 2 from both sides, right? And I'm going to get y equals negative, then x minus 7 squared minus 2. That is f inverse of x. What did I do wrong? Oh, no, because I left this out here. Wait. Oh, yes, from the very beginning. Yes. Dang it. Okay, I thought, yes. Thank you. When I hear, I think I even said, I hope I said add 7. So yes, that should be positive. That should be positive. So all along the way. Yes, thank you. Sorry. And then remember, I have to state my domain restriction that I don't really have room for. My domain here has to be negative infinity to negative 7. And then we're going to look at why we have to have that. Because if I was to graph this, right? This is a parabola. I would take this parabola and I would reflect it in the x-axis, right? And then I would move to the left 7 and down 2, like here. And then if it's going to look something like this. I don't get to have the entire parabola, right? I only get to have it from negative infinity to negative 7. I only get part of it. That's why I have to have that restriction there. Okay? Oh, wait. I don't reflect in x. Y'all are letting me mess up again. What do I reflect in? Oh, my gosh. I think Hawaiian Day has gone to my brain. This is inside the parentheses. What do I reflect in? Y. And I was thinking to myself the whole time I'm doing this is not right. Okay. So if I'm here and I reflect in y, the parabola is going to look the same, right, when you start. So I reflect in y, nothing really happens. I move to the left 7 and down 2, so it looks like this. It's not flipped upside down, sorry. But my domain, I only get to go from negative negative infinity to negative 7. That's the only piece I get to use, because when I reflect that in the line y equals x, I end up with this piece. Like I can't get the whole thing because I only had part of it to begin with. That's why I have to use a domain restriction. Okay. What questions do you have? All right, so let's look at 12. This is an absolute value function. I'm going to reflect it in which axis? X. So now it's opening down. And then it gets stretched a little bit, and then I move to the left one, so it's like this. Is this a one-to-one function? No, it is not. So I can just say not one-to-one, and then we don't have to do any work. This is a cube root. It looks like this. Is it one-to-one? Yes. Do I have any restrictions on the domain? I'm sorry, on the range? On either one of them? No, it's all real numbers on both of them. So there won't be any restrictions on this one. Okay, so I'm going to set this equal to y. X and y switch places, so the cube root of y minus 9 over 4 equals x. See if you can solve that for y. that's what I ended up with. Do you agree? Do you have questions on where anything came from? No need to actually multiply out that, like, there's no need to cube that 4, because again, if I was graphing that, I'd kind of want it like that, make things a little bit easier. What questions we got? All right, so let's look at number 14. They start us with a restriction. Okay, so I'm starting with a domain restriction. This is a quadratic, so it is a parabola. When I graph it, it's going to be vertically stretched a little bit and it moves down one. So it's going to look like this. That's what the parabola looks like. But there's this restriction here that says x has to be greater than or equal to 0. So x is greater than or equal to 0 right here. So I don't get to use the whole thing. I only get to use that right-hand side. Is just that right-hand side a one-to-one function? Yes. If that's all I have, then I'm good. If I had the whole thing, then the answer is no. Okay, so I know there's a restriction on the domain because it gave it to me. Is there a restriction on the range? Or is it all real numbers? No. What's the smallest y I get? -1, and then I get to go to infinity. All right, so that's the range restriction on the original, which will become my domain restriction on my inverse. All right, so I'm going to set this equal to y, and I'm going to get 3x squared minus 1 equals y. So you go ahead and solve for, no, I just wrote down the same thing because holy crap, yeah. Oh my goodness. 3y squared minus 1 equals x. Yeah, so solve for y. I was about to say solve for y, but oops, it already was. Okay. You might want to write it like this instead of all over 3, because if you want to think about when you're graphing, that might be a better look for it. Plus, if we didn't, then we'd have to rationalize the denominator, and we don't want to have to do that. To undo a square, I'm going to take the square root. So y is equal to plus or minus the square root of 1/3 times x plus 1. Now, I got to think about, do I really want the plus or minus part of this? The plus and minus, that gives me a top half and a bottom half to a sideways parabola. I don't want both of those. I just want the top half, so I really just want it to be positive. So my inverse function is actually just the square root of 1/3 times x plus 1. And then my domain restriction is the same as this range restriction. It's -1 to infinity. What questions do you have? Anything? We good? All right. Did it sound familiar from Algebra 2? Hopefully. The domain is what's a little bit different there, but I don't think you have too much of that. There's not very much domain stuff in Delta Math, so you're good.